Hello and welcome to this video, a part of All About Silica series, where we dive into the world of silica and explore its different types. Silica comes in many forms, but in this series, we'll focus on the ones most relevant to the adhesives and resins industry. This is the sixth video, and in this video, we're going to talk about silica gel and its properties. Stay tuned and enjoy. Now let's focus on the third category of amorphous silicas, synthetic amorphous silicas. This subcategory includes various types, one of which is silica gel. Silica gel is an amorphous, porous form of silicon dioxide, SiO2, composed of a three-dimensional, irregular framework of alternating silicon and oxygen atoms. Within this framework, nanometer-scale voids and pores are formed, which can contain water or other liquids. When these voids are filled with gas or vacuum, the material is referred to as silica zero gel. Silica zero gel has an average pore size of approximately 2.4 nanometers, and it exhibits a strong affinity for water molecules, making it widely used as a desiccant, a substance used to absorb moisture in the industry. Despite being hard and translucent, silica zero gel is considerably softer than solid silica glass or quartz and contains its hardness even when saturated with water. It is typically commercialized as coarse granule or beads ranging a few millimeters in diameter. Some silica zero gel granules may even contain a small amount of an indicator substance which changes color when the material absorbs moisture, providing a visual cue of the absorption process. The synthetic process for producing silica gel was patented in 1918 by Walter R. Patrick, a chemistry professor at Johns Hopkins University. This innovation marked as beginning of the widespread commercial production and use of silica gel in variety of industries such as moisture control and packaging, chromatography, and as a catalyst support. Silica gel and silica zero gel are key members of the synthetic amorphous silica family, each with its unique properties and uses based on their ability to absorb moisture and their structural composition. Silica gel is available in three main types, each with distinct properties and uses. Type A: clear pellet with an approximate pore diameter of 2.5 nanometer. These pellets have excellent drying and moisture-proof properties. They can be used as catalyst carriers, absorbents, separators, and variable pressure adsorbents. Type B: translucent white pellets with a pore diameter of 4.5 to 7 nanometer. These are liquid absorbents often used in applications like drying, perfume carriers, and catalyst carriers. And type C, translucent with a micropore structure. This type is primarily used as a raw material for preparing silica gel cat litter. Additionally, when dried and screened, it forms micropored silica gel, which is used as a dryer, absorbent, and catalyst carrier. Silica gel is notable for its high specific surface area, around 750 to 800 square meter per gram, which allows it to absorb moisture effectively, making it a popular desiccant drying agent. In fact, silica gel can absorb up to 40% of its weight in moisture in high humidity environments. The moisture it absorbs is stored in the numerous pores of its structure, not absorbed into the bulk of the gel. These characteristics makes it effective in moisture control applications such as in packaging, electronics, and pharmaceutical. When silica gel becomes saturated with moisture, it can be regenerated by heating it to 120 centigrade for 1 to 2 hours, which releases the moisture and restores its drying capacity. This process allows for multiple uses of silica gel with minimal loss in efficiency. However, certain types of silica gels may pop when exposed to sufficient water due to the breakage of the silica spheres. Preparation method. Silica gel is typically prepared by acidifying an aqueous solution of sodium silicate. This results in gelatinous precipitate, which is then washed and dehydrated to form colorless silica gel. To indicate the moisture content of the gel, ammonium tetrachlorocobaltate 2 or cobalt 2 chloride is often used as an indicator. Cobalt chloride turns blue when dry and pink when hydrated. However, due to the association between cobalt chloride and cancer, its uses in silica gel has been banned in Europe. An alternative indicator, methyl violet, is sometimes used, which turns orange when dry and green when hydrated. Silica gel is a highly versatile material with various forms and applications, especially in moisture control and as a desiccant, catalyst carrier, or absorbent. Its ability to absorb moisture and be regenerated makes it highly efficient and reusable. Silica gel is a versatile material with a wide range of uses across various industries thanks to its exceptional moisture absorbing capabilities. Here is a breakdown of some of its key applications as a desiccant or moisture absorbent. In terms of moisture absorption, we could say that silica gel can absorb up to 40% of its weight in moisture, significantly lowering the relative humidity in a closed container, often to about 40% RH or relative humidity. This makes it an ideal choice for preventing damage to products sensitive to moisture, such as electronics and foods. Reusability. Once silica gels become saturated, it can be regenerated and reused by heating it about 120-130 centigrades, which drives off the moisture. Air drying. Silica gel is commonly used to dry the air in industrial compressed air systems. In these applications, compressed air follows through a bed of silica gel beads, effectively removing moisture from the air before it reaches sensitive equipment. In chromatography, stationary phase in chromatography, silica gel is widely used in chromatography columns, where it serves as a stationary phase in the separations of different compounds. In porous structure and surface properties make it highly effective for separating substances based on their interactions with the silica surface. And in cat litter, silica gel is used as a key component in cat litter. It is non-tracking and virtually odorless, which makes it an excellent choice for litter boxes. It can be used alone or combined with traditional materials like bentonite clay. The silica gel absorbs moisture and controls odor's efficiency. Food additives, generally recognized as safe. It could be said that silica gel is FDA approved. Silica gel listed as a synthetic amorphous silica SAS or silicon dioxide is a GRAS, generally recognized as safe material by the FDA. This means it can be added to the food products without requiring further approval. In the US, it is permitted in concentration of up to 2% under the regulations. Common uses in food. It functions as an anti-caking agent, defoaming agent, stabilizer, absorbent, carrier, conditioner, chill-proofing agent, filler aid, emulsifier, viscosity control agent, and anti-settling agent. In water filtration, ion exchange. Silica gel is sometimes used in domestic water filters due to its ability to absorb certain minerals dissolved in water. Its surface structure allows for ion exchange capabilities, making it useful for improving water quality by removing unwanted elements. Moisture indicator. Daubed with color indicator. Silica gel can be daubed with a moisture indicator, allowing it to change color as it transmits from anhydrous state into the wet or hydrated state. This visual indicator helps user easily monitor when the silica gels need to be regenerated. Okay, so now let's give a summary of that. In desiccant, it can be used in desiccants for moisture control in packaging and air systems, in chromatography, stationary phases in separation processes, as a cat litter, non-tracking odorless moisture control. It can be used as a food additives, anti-caking, stabilizing, and defoaming agent in that industry. In water filtration, it can be used for absorption of minerals or cleaning the water. And also it's a moisture indicator, color change to show the moisture absorption. Silica gel's ability to absorb moisture combined with its versatility across a wide range of industries, from food processing to water filtration, makes it a highly valuable material. Its reusability, safety profile, and effectiveness in moisture control continue to drive its use in both industrial and consumer products. Thanks for your attention to this video. In the next video, we will cover another type of amorphous silica, which is colloidal silica.